AQA Physics 2 Complete Revision Notes. Feel free to pause the video and make notes. I would advise that you download this video as an MP3 file and listen to it whenever you can. Make sure you understand what is being said. This is the most important thing. Every force has a reaction force that is equal in size and opposite in direction. Forces can be added or subtracted to produce a resultant force. The downward force that you feel when you carry something is its weight. If there is no resultant force on an object, it will carry on doing what it was doing before. Forces can change the shape of objects. When a force squashes or stretches an object, the energy is stored as elastic potential energy. The extension of a spring is directly proportional to the force applied, provided the limit of proportionality is not exceeded. Force equals spring constant times extension. Speed equals distance divided by time. Velocity is speed in a given direction. The area on a speed-time graph is the distance covered. Acceleration is change in velocity in a given time. Force equals mass times acceleration. Acceleration can be calculated from the slope of a velocity time graph. Measurements must be in the correct units for calculations. Frictional forces act to slow moving objects down. Braking increases the frictional forces on a car. Faster moving cars take much longer to stop than slower ones. Stopping distance is thinking distance and braking distance added together. A number of factors affect braking distance, including drug and alcohol consumption, tiredness and the condition of the car, the tires and the road. Forces resisting motion depend on a range of factors including size, speed, surface, shape, and the fluid the object is moving through. Terminal velocity is reached when weight is balanced by drag. Weight is the force due to a gravitational field acting on a mass. Weight equals mass times gravitational field. On the Earth, this is about 10 newtons per kilogram. Work done is energy transferred. Work done equals force times distance. Energy is transferred when a force acts through a distance. Energy is never created or destroyed. Lost energy usually ends up as heat. Power is the work done or the energy transferred in a given time. Power equals energy over time. Power is measured in watts. 1 watt equals 1 joule per second. Gravitational potential energy is the energy that an object has due to its position in the Earth's gravitational field. Change in GPE equals mass times gravitational field strength times change in height. An object's kinetic energy depends on its mass and its speed. Momentum is mass times velocity. Momentum has direction like velocity. Increasing the time that a person in a car takes to slow down reduces injury. A closed system is one where no forces act from outside the system. In a closed system, momentum is always conserved, so total momentum before a collision equals total momentum after a collision. Anti-lock braking systems detect when a car's brakes are about to lock and reduce the braking force to prevent skids. Kinetic energy recovery systems store some of the car's kinetic energy as electrical energy instead of losing it to heat on braking. Seat belts, airbags, crumple zones and side impact bars help reduce injury to car occupants by reducing the forces on them during sudden deceleration. Some insulating materials gain a static charge when they are rubbed. If materials gain electrons, they become negatively charged. If they lose electrons, they become positively charged. Objects with the same electrical charges repel each other. Objects with opposite electrical charges attract each other. Electrons can move easily through metals. A flow of charge is called an electric current. We can measure current in terms of how much charge flows in a given time. Current equals charge divided by time. The potential difference between 2 points in an electric circuit is the work done per coulomb of charge that passes between the points. PD equals work done divided by electric charge. Current, voltage and resistance are linked by Ohm's law. Potential difference equals current times resistance. The current through a fixed resistor is proportional to the voltage across it, as long as the temperature remains constant. LDRs and thermistors can be used to sense light and the temperature levels. The flow of current through some components is proportional to the voltage applied to them. Diodes only let current pass in one direction. Old-style filament bulbs are much less efficient than LEDs or compact fluorescent devices. Electrons convert energy from electrical energy to heat energy when they pass through a resistance. When currents join or split, the smaller currents always add up to the same size as the larger one. If two components are connected in parallel, each will have the same PD across it. The total resistance in a series circuit is the sum of the resistances of the individual components. Potential difference across each resistor equals total PD times resistance of resistor divided by total resistance. In parallel circuits, the PD is the same across each branch. The current through each branch depends on the resistance of that branch and can be calculated with V equals I times R. Cells and battery supplies direct current, electricity. This is a constant flow in one direction. Mains electricity is usually alternating current, in which the current and voltage change direction frequently. Mains electricity in the United Kingdom is at 50 Hz and 230 volts. Cathode ray oscilloscopes can be used to work out the period and frequency of AC voltages. Plugs and cables are used to connect electrical devices to the mains electricity supply. Wires are color-coded to make identification easier. Most electrical devices use a 3-pin plug. 3-pin plugs must be wired correctly. Appliances of different power need different thicknesses of cable. The earth wire and fuse in a 3-pin plug together help make appliances safe. Residual current circuit breakers can protect people from electrocution. Both circuit breakers and fuses act by breaking the circuit. Circuit breakers are more sensitive than fuses and they act more quickly. The charge that flows in a circuit depends on the amount of current and the time. The larger the voltage that pushes the charge, the more energy the charge transfers. Electrical power output is current times potential difference. It will be useful to know how to use the following equations. P equals E over time, P equals V times I, Q equals I times T, and E equals V times Q. Atoms are made up of protons, neutrons, and electrons. The number of protons in an atom determines which element it is. Isotopes are atoms with the same number of protons in the nucleus but different mass numbers. Electrical charges are responsible for keeping the particles in atoms together. Atoms have an overall charge of 0. Ions are atoms with extra or too few electrons. The radioactivity of a source is unaffected by any physical condition we can control. Radioactivity is a property of the atomic nucleus. There is background radiation around us all the time, and most of it occurs naturally. One element can change into another by alpha or beta emission. Different types of ionizing radiation have different ranges and penetrating powers. Ionizing radiation can be very damaging to cells. Alpha and beta particles are both deflected by electric and magnetic fields. Alpha sources have many uses, for example in smoke detectors. The modern model of the atom places most of the mass of an atom in a small nucleus. Radon gas is responsible for the majority of background radiation. Alpha sources are very dangerous inside your body. Beta particles are more penetrating than alpha particles and less penetrating than gamma rays. Beta particles have many uses, for example in treating cancers. Gamma rays are used, for example, as tracers in medicine. The half-life of a sample is the time it takes for the activity to reduce by half. In other words, for half of the atoms to decay. Carbon content can be measured to find the age of some organic materials. Although radioactive decay is a random event, if you measure radiation over a long time, the level of radiation emitted is predictable. Background radiation is all around us. The majority of background radiation is from radon gas given off by rocks. The proportion of ionizing radiation in background radiation that is due to human activity is very small. Using nuclear power carries risks and creates very long-lived radioactive waste. The effects of nuclear incidents will last a very long time. Ionizing radiation can cause health problems which are more likely if the dose is larger. Precautions are taken where people work with ionizing radiation. Nuclear fission is the splitting of a nucleus. When a uranium nucleus splits, it gives out energy and neutrons, and elements with smaller nuclei are formed. Nuclear power plants use the energy from nuclear fission to generate energy. Uranium is the most commonly used in nuclear fuel, but plutonium is also used. Nuclear power has a number of key advantages and disadvantages. In nuclear fusion, the nuclei of lighter elements fuse together to form heavy ones. Nuclear fusion takes place in the center of stars. It is very difficult to make nuclear fusion take place in a controlled way on the Earth, as the temperatures needed are so high. The force of gravity contains the nuclear fusion taking place in the heart of a star. Stars that have smaller masses will end their lives differently to heavier stars. Stars form when gas and dust condense under gravity and eventually become so hot that fusion starts. Fusion creates the elements heavier than lithium. Elements that are heavier than iron are formed in supernovas. Planets are formed by the heavier elements in a dust cloud gathering together in a disk and eventually forming bigger and bigger lumps. And that's about it. P2 is finished. I did a video on P1 and all that's left is P3. Hope this video was helpful, and yeah, good luck with your exams.